So next is Jim Cowie with Renesas. Up next. Oh.
Hey y'all, I'm Jim Cowie from Renesas. I'm here today to talk about some of the uncomfortable truths of the internet. It's been known for some time, and it's caused some concern, that a very small minority of all the prefixes in a full DFC table actually contribute a very large portion of the instability that we see, the total number of BGP updates that are exchanged. It may be as small as 1% each day, and they may be contributing 50 or even 60% of the total BGP traffic. And there's been some speculation about where those are. What I'm going to do today is show you some experiments that I've been doing over the last couple of months, looking at the last year of traffic, trying to figure out what these unstable prefixes have in common. And just to cut to the chase, we find that they're not uniformly distributed. And in fact, what they have in common is their transit, the transit path, both the origin and the people upstream. So what we're going to do is propose some simple methods for scoring any of your ASs according to the stability of your customer cone. And so you need to sit up because you may be in this talk. We're going to call you out. Here's my favorite XKCD. I don't know if you can see it. Little Renesas guy, a stick figure, is standing at the blackboard. He says, our relationship entered its decline at this point. And the NANOG community off screen says, that's when you started graphing everything. And he says, well, that's just a coincidence. So why do we care about route change? I mean, we've been looking at this for, Renesas has been looking at it for 8 years or 9 years. Here's why we care, right? Every time, obviously you know this, every time a route changes, you get the potential for packet delay or reordering or even loss. And if that becomes significant, then users somewhere are going to notice. And they're going to run trace routes, and they're going to do what users do, and they're going to blame you, even if you're not at fault, because you're providing transit to the people who are not maintaining a stable presence in the table. If this gets really significant, and because, you know, as Dave Meyer pointed out earlier, the control plane of the internet is in band. So if routing change gets really bad, your routers get hot, and then sessions get reset, and then it gets worse. If it gets really, really significant, then we all get to discover what a power law size distribution means for internet events, right? Complex, distributed, highly connected organizations don't have failure modes that look like a bell curve. You know, the probability of very large events doesn't fall to zero very rapidly. You know, the Roman Empire was too big to fall, too big to fail. Lehman Brothers was too big to fail. Tier 1 backbone providers, routing infrastructure is too big to fail. So instead of focusing on BGP update rates for the whole table as we have before, as I said, let's take a look at the subset that are consistently poor. And as I say, you know, if you look, about 1%, that's thousands of prefixes out of 250 or so thousand right today, are generating more than half of the BGP update traffic every day. So what we're going to do is we're going to identify the people who are unstable and the people who are stable. If you can find the unstable people, we claim that stability is kind of a surrogate measurement for the qualities that you would look for if you were choosing a customer or a peer or choosing who to do business with. You know, people who are stable have good infrastructure. They have clueful admins that take care of problems quickly. They engineer in advance of problems. They give you quiet enjoyment of your relationship with them. Now we're going to talk about the other people. First of all, you know, I'm standing on the shoulders of giants. There's a lot of people that have done a lot of fundamental research on BGP instability. As you know, sessions go up and down because everything dies all the time. It has this wonderful multiplicative property that one network going out can be perceived locally, depending on how rich your peering is, as hundreds of echoes. Because not only you're not simply getting the withdrawal of the network, you're getting the path exploration. All the backup paths that could have been going to that network are going to come back at you, right? It's been thought for a while that you could do flap dampening, and it turned out to be harmful. I mean, Sure, it caused instability to get damped down quick, but then in the long run, it really prolonged the convergence time. So practically what we're going to do is we're going to assign scores. And I'm going to propose one way. Y'all can take your own thoughts on this and construct competing measures, but here's a straw man measure that we're going to use. We're actually going to score every AS. What we're going to do is take its customer cone, everybody who's on net with it. We're going to measure their instability, calculate a percentage, assign you a score. Okay, so you can use these for bragging rights. You can tease each other. You could issue new exotic derivative securities based on them. Pays off based on UUNet's instability in February. Don't do that. We've had enough of that. I actually made that joke in October. It's not funny anymore. So stability scoring is quite difficult. It takes a large data set. You've got to look across a huge peer set. Everything is non-stationary. You have to look over long periods of time. The blame can be at the edge. It could be here in the core. It could be anywhere in between. And frankly, everybody's going to have some instability because the more prefixes you route, the more instability you're going to see. This is a kind of a difficult plot. I'll take a second just to go over it. It's sort of a probability distribution curve about instability. In the upper left-hand corner, it says, look, 100% of the routing table is going to have at least 0% instability. That is, it's going to be at least not stable. I mean, not unstable. And then this falls off, right? This is a log-log plot. This says that maybe 10% of the table, the worst 10%, is going to be unstable for more than 100 minutes in the sample period here, which is October 2008. And it just keeps falling, right? The worst 1% had 1,000 minutes of instability. The worst 0.1% had, and so forth. And you'll see that this goes on and on and on. And this is the bitterest part of the curve down here. I take a minute to explain that because we're going to pick this apart into different subpopulations. And we're going to see if they have sort of visibly the same distribution. So the theories we looked at were age. So is it true that the longer a prefix has been in the table, maybe prefixes that survive in the table get more stable? CIDR length, maybe /8s, maybe classical prefixes flap less, maybe they flap more. Geography or transit. So first of all, just to rule it out, age does not imply stability. I apologize for the red-green. The curve on top is the total number of prefixes that we've seen enter the global table at various dates in time. The big outlier at the left is everybody before 2002. And the curve down below is the same thing for the unstable, the observed unstables. You can see they have the same shape. They correspond, except for the very end where you'll see, let me go to a percentage view. Generally, except for the very young and foolish, prefixes younger than 30 days, basically prefixes, age is not strongly deterministic of the instability. Here we pick the same curve apart into the prefixes that were born, happy birthday, on 2005, 2006, 7, 8. All the curves basically look kind of the same, which is my seat of the pants way of telling you that they have the same kind of instability distribution. The purple is 2008, which is still a little fresh and a little unstable. Size doesn't do it either, right? Among unstable prefixes, you see significant percentages of basically every CIDR length being unstable during the month. Where you do see an actual difference is in transit. Here on top, this is the same curve for origination, ASs that originate at least 10 prefixes. The red just below it, if you can see it, is transiting 10 or more prefixes. Below that, distributing over the country that originated it, and below that, one for US states. And you can see that on the right side, this just keeps going, right? There are significant numbers of originating ASs and transit ASs that have really pretty bad records at keeping their prefixes stable. So the question becomes, how many of these do you have in your customer cone? Well, here, let's find out. All right, here's my score. Let's just take a definition of impacted. So you take any prefix in the routing table, and we'll come up with a decision about whether it has been impacted in a given hour. Here's my definition. I say if I saw that prefix get withdrawn at any point in the hour, it's impacted. I also claim that if using the traditional route flap algorithm, if you get at least 3 flaps in at least 5% of the 30-second windows in the hour, seen by, and here there's a typo, it's not majority of peers, it's about 10% of peers, which is large enough that I'm not measuring the instability of my peers, but I am catching regional effects, then you're impacted. Now, we simply take your customer cone, we know who's on net with you, we divide out the percentage of those prefixes that were impacted, and that's your score. All right, everybody got that? All right, let's play the feud. We're going to grade you on a curve, just because everybody likes letter grades. It's a very steep curve because, make no doubt, most of the internet is stable. 99% plus is how you get an A. I'll show you in a second that most of the internet is, in fact, planet-wide an A. 98% you'll get a B, 95 a C, 90 a D. If more than 10% of your on-net customers are unstable, you get the big F. Now, if you look at, this is the breakdown of transit customers, first hop customers, that have these grades across the providers, you'll see that this curve is pretty appropriate, even though it looks very steep. The vast majority of each of the default free zones transit customers are pulling A's, all right? And there's some B's, some C's, some D's, and a few F's. If you look at the whole planet, here's the number of networks that are impacted according to this working definition. About 0.62% in your average hour, so that's an A. Good job, planet Earth. There's a 7-day cycle you can see here. You see the bursts and the peaks and valleys. And you can, the naked eye event that you see here is the big mysterious triple cable cut in the Mediterranean on December 19th, which we'll get back to, because it plays into some of these stories we're going to tell. As I say, there's a 7-day cycle. Here is that 7-day cycle. If you take instability, the time series, and you wrap it around the 7-day clock, higher than average instability is on the outside of the circle, lower than average instability on the inside. You can see the weekend over on the left. You can see the daily cycles of something over on the right. We can argue about whether that's traffic, because it's the diurnal cycle of traffic, or whether it's your working hours. You'll see that if you take the top 20 ASs worldwide, the key does not correspond to the height of the level. You see that if you take the median impact, percentage impact for each of the top 20, it's pretty stable. For each provider, there is a characteristic level at which you hover. It's not as if you go up and down. That's because the largest ASs have very large customer bases, and so if you add the characteristic instability of a large pool of people, you get a number which is pretty solid from measurement point to measurement point. So, actually going to run through this and show some examples. Now, Telia versus Teleglobe has always been my calibration exercise because they're both well-run networks. They both... Somebody's laughing. Don't laugh. This is science. They're both well-run networks. They have what I would characterize as different approaches to adventure, right? Telia, pretty safe customer base. Teleglobe is in the adventurous part of the space. They're not afraid to provide transit to people all over the world. But if you look at them, Teleglobe Tata is in brown, Telia is in blue. What I've done here is I've taken the percentage instability in every hour between July and December of last year, and I just plotted it. So you see kind of a scatter plot, and you see two things pop out at you immediately. One is there is, as I said, a characteristic instability level for these providers towards the bottom, and it's pretty low, right? Consistently under 1%. That's the A ranking. There's also moments of, I call them bursts of failure, right? Where instability can jump for short or long periods of time, above 1% to 2, 3, 4, 8%. It's not an artifact. The feature that you see here at the right side of the plot is Teleglobe's handling of the cable cut in the Mediterranean. Now, this is, again, an important point to realize. I'm not saying that Teleglobe caused this instability. That would be the farthest thing from what I want you to conclude. What I'm saying is that Teleglobe serves some customers who had impact. They became unstable. Now, Teleglobe worked heroically to get those guys back on their feet and to improve capacity and to make them not be stable. So in the future, we can anticipate that their customer base will be more stable. But during this event, as we measured it, they and everybody else who is upstream of those will have the same impact on their stability score. So if you compare them, you can claim a winner. It's really close. I think there's only 0.4% separating the two. And so you might almost give the win to Teleglobe Tata, given that they have a more adventurous global customer base. But basically, the intuition is perceived. Telia is here spiking up, Teleglobe down. You can see that in the average hour, taking each hour as a head-to-head battle between these two, which is artificial, Telia would have won 50.6% of those hours, Teleglobe 49.4%. So very evenly matched. The next one I'm going to illustrate. Yes, sir.
On a previous slide, hadn't you said the cable failures?
Yes.
Right. So go back to that slide. So
yeah.
Isn't that big spike the cable failures?
Yes, it did. It is.
Didn't that disproportionately impact 6453?
It did indeed.
So if that were taken out, what would those percentages be? Better, different, the same?
The score here, and I think I neglected to mention it on the slide where I proposed it. We take all of the instability scores for all of the hours in the period, and we do a 95.5. Okay, I forgot. This is actually a critical thing. It's, you guys understand bursting, and you understand making people pay for their worst burst. We take 95.5, and so yes, if this event were out, I'm not sure. It was a pretty sharp event, as you can see. It's a pretty short spike, and so yes, if you took that event out, it's possible that Teleglobe Tata's 95 might have gone up.
I see.
And
Thank you.
Yes, they could be winner. Thank you. Good clarification. So the next one is AT&T versus China Telecom. There's no real reason to compare the two other than for entertainment value. I mean, they're both ex-national monopolies that have mutated into wonderful new business models. What you see here, again, lower is better, and the brown is China Telecom. China Telecom wins in the average hour. They are more stable, or I shouldn't say they are more stable. Their customers, their on-net customers are more stable. But they have more sporadic failure. So one of the interesting things that we as a community have to work out is how much weight do we put on average hour instability versus peak hour instability. I give the win here to AT&T because in the 95.5 measurement, AT&T pulls in 99.16, which is an A. China Telecom in 98.11 because they do have bursts, similar to what Todd was pointing out in the cable cut slide. China Telecom is more stable in 2 hours to every 1 for AT&T, but they have 3 times the high instability hours, where more than 1% of their on-net prefixes were unstable. You can break these out. I should have done this for Teleglobe Tata. They have these excursions from normal, where they're providing transit to hundreds of Vietnamese and Cambodian prefixes, and the China Education Research Network Center in Viettel, where the bottom drops out, and suddenly 8% of their on-net prefixes are measurably unstable. And those are not sharp spikes. Those are reasonably thick, and they happen over and over. And if China Telecom were to come in and say, I want to improve my assessment of stability here, I would say, well, it's clear where you look. I mean, 98-point-something% of your prefixes are fine. And you've got a small population of people that you have to talk to on the phone if you want to have a disproportionate impact on reducing the routing instability that the whole world sees day and night. AT&T has fewer unstable downstreams, and they're more globally diverse, as you would expect. Some Mexico, some Saudi, Malaysia, Korea, China. If we compare Verizon, UUNet, level 3. Again, this is the hourly percentage unstable on net. Lower is better. And you can see here with your naked eye, there's a pretty much larger difference. Level 3 in blue, level 3 in brown is more stable overall, and they're less bursty to boot. Up and down is hard to tell, but if you diff them, you subtract below from above, you can see the relative instability in each hour. That's this plot in the blue. you can see that while old UUNet pulls a solid B at 98.8%, level 3 breaks 99% and gets the A. They're more stable in more hours, 4 to 1, and they have many fewer high instability hours where they burst out of the A range. I can't emphasize enough, I'm not talking about level 3's backbone stability. I'm not talking about level 3's engineering quality. I'm just talking about the distribution of people that they have on net with them. If you look at the two, they both have similar geographic patterns of instability. Lots of C's and D's and a couple F's of major providers around the world, Pakistan, Russia, Malaysia, Romania, Singapore, who had several percent, up to 10% plus, of their prefixes unstable in the 95.5 hour, which is pretty impressive when you consider we're looking at 6 months of data. Here's another great example. Here's Turkish Telecom versus Bulgarian Telecom, kind of a great 19th century kind of matchup. So 9121 takes on 8866 in the big ring. These are smaller carriers. As you would expect, smaller carriers have bigger problems. This change of scale, you can't read it, but the graph here for percent unstable in the 95th percentile hour goes up to 80 or 90%. Head-to-head, the Bulgarians take it. They get a C. TTNet gets a D. And I'll show you why. The Bulgarians are big winners in the average hour. They have fewer hours where they burst to F, 10% plus unstable. So again, what was TTNet doing here? Well, they have people on net who live in the adventurous part of the internet. They have hundreds of prefixes from Georgia and Armenia through United Telecom, who got an F. They have hundreds of prefixes through IDC from Iran, who also got an F. And of course, in the spike, during cable cut, they have over 1,000 Egyptian prefixes transiently on net from TE Data, who got a D. They were providing transit, at least for a while, during the aftermath of the big cable cut. And so they got a big helping of the woe here, even though they didn't keep them in their table for long. Here's the big one. Thought you guys would like this. Sprint versus Cogent. Who's going to be more unstable? Is it the well-respected, upstanding citizen, #1 ranked global transit provider? Or is it the cheapest deliver solution who built their business on rock-bottom pricing? Who would you expect to be more unstable? Wait for it. Lower is better. 174 is in brown. It's a tie in the rankings, right? They're within 0.05% together in the 95th percentile hour over 6 months, which is interesting. But I give it to Cogent. The reason I give it to Cogent is that they win head-to-head down in the 95th percentile fat part of the hours, 3 to 1 in 3 hours to every 1 hour that we compared in July through January, July 2008 through January 2009. And they have roughly the same number of hours bursting above the 1%. Again, what was up with Cogent? Everybody, there's a common pattern here, which is that, remember, Turkish Telecom got woe because they were helpfully providing transit to people who were in affected regions in the Middle East and elsewhere during the cable cut. Well, Cogent provides transit to Turkish Telecom, right? So they've got the same people on net with them. And so they get their share of the woe. Sprint had a little bit of transit to Telecom Italia, who pulled a good solid B for similar customers, and so you can see a little spike there at the moment of the big triple cable cut. Sprint, being larger, has a more diverse global population of on-net customers who were unstable. People from Costa Rica, GTS Central Europe and Germany, CNC Group, and the Saudis who got an F. So, in conclusion, why should you care about these numbers? People get worked up about numbers as soon as you take a look. The message here, I think, is that some prefixes really are significantly more unstable. This is not sort of a random sample that gets uniformly distributed across everybody and it's just a fact of life and you have to get on with it. No, there are actually providers in the world whose prefixes contribute a disproportionate share to the instability of the global table. And every router in the world pays that instability tax in terms of the load on the router and the time to convergence and everything else. And so, as a community, I would suggest that it's time to come up with some metrics, if not these metrics, then other ones that you would propose. Go out, take a look at the data sets. Go to route views, go to write. Find data sets that cover over long periods of time, large numbers of peers, and figure out for yourself who your on-net customers are, whether they're your customers immediately or your customers' customers' customers, who are contributing disproportionately to route instability. I think this should be considered sort of a tragedy of the commons that people are able to pollute the daily table with instability. The only way around that is to measure it and to manage it and to talk about it. And I think that I'm really interested in hearing more people talk about identifying the people who are doing good jobs at identifying their customers who are being unstable, tracking them down, and helping them rise in clue to the point where they don't make things so miserable for everybody else. We can only hope that if we start talking about it and we get some concrete objective metrics out there, maybe we can get to the point where an enlightened customer who comes to you can say, I took a look at your network, I want to be on net with you, because the people who you have on net are significantly more stable than the people who your competitors do, even though maybe they're charging a cheaper rate. Can we hope for that as a point of differentiation? So thanks, that's all I have. I'll take questions. Controversy, questions, criticism. Poke me with pointed sticks here.
That day cycle thing, those are days where? Is that days UTC? Is that...
It's days UTC on the plot. You can inspect this at some length because these slides will be up later on the Renesas site. I looked at that too. The peaks of those sort of seem to correspond to Central Europe, but the signal is really broad because you're lumping together work days from Europe, from Middle East, from Asia, from North America. It's not in North America, which is what you'd expect. I'm sorry, it is UTC.
But there is a genuine day of the week correlated instability cycle that corresponds to the largest amount of stability being Friday, Saturday, Sunday, UTC.
It's actually, it's late Friday into Saturday, Sunday, and then leaking into Monday, UTC.
Fascinating.
It was hard for me to explain. I looked at that. I thought maybe I calculated it wrong. I did it 6 times. Maybe you guys, you come to work on Monday and you're like, oh, I'm not going to touch routers today, or don't know.
Okay, thank you.
Hey, Jim. Donnie with Peak Web Consulting.
Yep.
Thank you very much. If I'm reading this correctly, you're holding the transit providers accountable for the behavior of their downstream customers.
That's unfair, isn't it?
Is it unfair? Is it maybe, worst case, open to sabotage?
That's a nice point. I think that it has more to do with the blend of customers that you have, right? I think even a single customer going bad it would be hard to move the needle on a big carrier.
Okay.
I could be wrong. I don't think it's fertile ground for sabotage.
Clearly not right.
And sure, right. And then is it immediate downstreams or is it all the downstreams following?
It's all the way down to the bitter end.
Okay.
So it is fundamentally unfair on the face of it. This is why, if I haven't issued this disclaimer enough, I'll do it 3 more times. I'm not talking about the quality of backbone engineering. I'm not talking about the quality of your gear or your people or anything. I'm just talking about the population of people that these guys have brought on net with them as customers.
That's the quality of your sales staff, actually.
Right.
Thank you.
I like that.
So to Dave Temkin, so to Danny's question,
Yes.
Has any work been done to more or less weed out whether or not it is a quality of customer thing? So the Sprint versus Cogent slide,
Right.
Where you think of the average Cogent customer next to the average Sprint customer and think of the expertise behind that network.
Right.
To try to figure out, hey, is this, they don't know how to manage their network, or they're more likely to take their entire network offline for maintenance, they don't have any redundancy within their network,
Right.
versus a Sprint customer who is more likely to, and then when you look at that, aside from normalizing the number of customers, thinking about it in a way such as, in that case, perhaps it's more a Sprint problem than it is a Sprint problem than a downstream customer problem, whereas Cogent would potentially be more a downstream customer problem.
Right, and there's a little bit of a blame the victim quality smell to these numbers, right? Because you're saying to somebody, if you don't have top tier talent on your engineering team, you're going to have more instability, which is, it's demonstrably true, right? You get the little guys, the people who don't go to NANOG, they don't have as much experience in really bad situations. They haven't seen as many really unusual cases, so they can't respond quickly, so they make things worse. And it is. You're right, and it is very much a function of the customer base clue. So the question is, if you're choosing to join a provider, do you want to, if you had the extra information available, wouldn't you want to consider paying a little more perhaps for a customer that had, for a provider that had a customer base that was more like you, that had clue and good kit and, was not falling over all the time?
Well, the question is, can you take advantage of that conversely? And
Right.
live in the valleys that are created by the clueless customers.
Right.
Thanks.
That is the adventurous part of the internet.
Hi, Patrick Gilmore, Akamai Technologies.
Hey.
I wonder why you picked the 95th percentile. That's, I understand why we do that when you're billing for, well, actually, I'm not quite sure why we do that when you're billing for bits. But the problem here is if I have a base rate of 1% and then for 36 hours a month I go up to 90%,
Right.
that's going to be much more important to me as somebody else on the internet seeing that 90% flapping very, very badly. The 1% is just noise. The routers don't fall over. Everybody handles it. And the only people who are really affected are the people the prefixes which are doing the flapping.
Right.
When you're at 90% flapping, then you can affect the entire global routing table. So by taking those spikes out, I'm not sure that the measurement is showing what it should show. Mm-hmm. And then the other thing I'd like to point out based on the Cogent comment that Cogent versus Sprint is or actually take out Cogent and Sprint. There's a lot of providers where you have backup transit where you're only sending data out and not announcing your prefixes. So
Right.
even if you're clueless,
Yes.
it doesn't affect that transit provider.
That
so
is
you
true.
have lots of caveats in the data, but mostly I'm wondering, why did you pick P95?
I picked P95 because it's as a rich tradition. You guys would immediately understand what I meant when I said 95.5. You're right. I did not do systematic exploration to find the sweet spot at which it would make a difference. I buy your intuition that 90% might be a better cutoff.
Well, actually, I think a better cutoff is, 100%. Fine,
Oh,
even if they have a really big spike, that's very interesting because that's where the global routing table is most impacted.
It might also be, I don't know how much time, it might be better actually to have multiple numbers, if we're working on this. One number that has a filter to take out the short spikes and another filter which allows the spikes to stand. Because there are prefixes that you're right, they just trip over a power cord and they're gone. And then they come back and then they're fine for 2 years. There's another population of prefixes that are out pretty much all the time. They fail and fail and fail and fail.
Just everybody who's up at the mics at this point. So.
All right. Anton Capella, 5nines Data. Excellent presentation, Jim. Thank you. I heard a little bit about it from another guy beforehand, but this is great.
Cool.
So one question that comes to mind is it possible to separate, or maybe you have and I just didn't hear it and missed it, events that are legit outages, link-related, whatever, from the repetitious or adaptive routing type stuff at the edge? And does there exist a correlation, if you did think about that, between the types of folks using said appliances and a specific kind of economy or ecology of upstreams?
It's a good point. I'm not quite sure how we would separate those two out, those two cases, and find appliance-based intentional engineering instability.
Right. Well, what struck me was you mentioned earlier that the sound of one route flapping, of course, is an echoing of path selection and exploration.
Right.
And does an outage's echo, look different from a TE echo? And maybe a TE echo is worse.
Right.
If they're well situated, let's say.
Yeah, I think this is actually related to Patrick's question about short duration versus long duration outage. Right, if people are pumping noise into the table day and night, this is a qualitatively different kind of damage that you're doing to the commons.
Right. Now, one other question I was going to ask you too was, did you see anything in the announcement traffic or the update traffic that wasn't necessarily like a complete withdrawal, but just a next hop changed, maybe just a path change? There was no actual like outages per se, but it was like a soft, if you will, selection.
Yeah, I mean, outage was only one factor in determining what was impacted. The other thing was that for at least 6 30-second samples out of the hour, which is 5%, you got up to a level of 3 on our old flap dampening algorithm calculator of badness. So it goes flap, flap, flap. That's an observation. Do that 6 times in an hour, you're out.
Thanks.
Dan McGorian from Max. Yeah, thanks. It's very good. Going a little further, I think what you're sort of implying here without saying is that, in fact, there's a bottom-end class of customers who should not be BGPing at all. Once you adjust for events and so forth, that all the various sales staffs should not actually be selling to those people, and that somebody ought to proxy for them and that for them, or some other kind of scheme like that. I mean, that's going a little further in this. But
I like the observation. I'm not trying to say that. It's not that I'm not saying it because I'm trying to say it but not saying it. I'm really not saying it. But I think there probably is a population of people out there who are vulnerable and yet who are trying their best in some very out-of-the-way places to be on the Internet with diverse transit. I think that should be applauded.
Well,
I just want to recognize them and maybe get them some help.
Well, they want to BGP because that's what all the big boys do, and they don't want to just be downstream from somebody else because they want to be their own players and do their own thing. But on the other hand, I think your numbers are showing that some of them are doing a pretty bad job of that.
I think some transit sales teams would love to sell more sort of captive customers and say, you don't need to speak BGP. I can handle all your needs.
Yeah, we understand the problem, but you know.
Yeah. I would encourage some of the people in the fragile tail who have wandered onto the net, who did get BGP, to just get some advice. And if these numbers should let us identify these sort of vulnerable populations and get some word to them, maybe even get them to attend NANOG.
Get a list to put a UPS in or something.
We can just buy them a UPS. It would be the cheapest solution to our problem. All right, thanks.